can make my own schedule, so if it's a lousy schedule, I can blame my...
An event of international significance in the year 1947 was the striking of oil at a place called Leduc in western Canada. It was the first of a series of strikes that caused the city of Edmonton, capital of the province of Alberta, to become the center of one of the great oil fields of North America. One after another they came in: Leduc, Redwater, Wood Bend, Golden Spike, Wizard Lake, and the rest. And within 3 years, the proven reserves in the Edmonton area were approaching 1 billion barrels and steadily growing. This would be a wonderful boon to Canadians, who had always had to import all but a small fraction of the oil they consumed. However, there was a problem of transportation to be solved, and the Interprovincial Pipeline Company was formed to build and operate a line that was to run from Edmonton to the head of the Great Lakes. Oil would there be loaded into tankers, which would carry it to refineries in Ontario for the benefit of the thickly populated eastern provinces. Construction of the interprovincial pipeline system got underway in the spring of 1950. It was Canada's first big long-distance pipeline. It was completed in record time, and in October of 1950, all of the line was safe underground with oil coursing through it toward the east. This was fine for eastern Canada, but it was of no help to the rapidly expanding economy of Alberta's neighboring province, British Columbia, where several refineries had to depend on oil imported by sea. It was logical that a pipeline be run to the great seaport city of Vancouver from the newly developed oil fields of Alberta. In December 1950, executives and engineers of several of the major oil companies and of the Bechtel organization began studying the routes that could be followed between Edmonton and Vancouver. Both by airplane and train, they crossed and recrossed the Rockies, traversing the main passes. They determined that the most direct feasible route lay through Yellowhead Pass at the western gateway to Jasper National Park at an elevation of only 3,720 feet. The Yellowhead Pass pipeline route would be a little over 700 miles in length, generally paralleling existing railway lines and roads. And so it was that Trans Mountain Oil Pipeline Company was chartered in Canada, and it was given a permit from the Board of Transport Commissioners to construct and operate an all-Canadian line. Canadian Bechtel Ltd. was designated as agent to design, engineer, and manage the construction. The line would initially serve refineries in the Vancouver area, but later, through an extension across the international boundary, it could also run oil to new refineries in the northwestern states. Through the spring and early summer of 1951, flights between Edmonton and Vancouver were made every day that visibility was good enough, until every mile of terrain along the route was photographed. Engineers studied the aerial photographs and tentatively plotted the pipeline route. To select the best locations in detail, the engineers and old construction men who worked with them had to get close to the ground. They covered some portions of the route with track loaders, which took them up and down through Coquihalla Canyon, one of the toughest places on the line, about 100 miles east of Vancouver, where the right-of-way would have to be carved around some spectacular slopes. They did plenty of walking, too. Often they had to take to the hills, as at Jasper Lake. They tramped through the woods, always seeking the easiest grades and the shortest distances, for big-inch pipelines cost more than $100,000 per mile. There was a long section on the western slopes of the Rockies where there was no real motor road at all, only a rough trail through the woods. It was a red-letter day when two reconnaissance parties met on a narrow road overlooking the North Thompson River in the wilderness between Kamloops and Jasper. One party was from the east, the other from the west, and this meeting marked the tying in of the initial overland inspection. The exploratory phase of the project was over. From now on, it would be up to the field engineers and surveyors to set their stakes and precisely fix the locations. But before any physical work could be done on public or private property, mutually satisfactory arrangements for easements had to be made. Local agents were sent out to deal personally with private landowners to state the requirements, answer questions, and effect settlements. Late in February 1952, clearing of the right-of-way was carried on wherever weather allowed and where access agreements had been made with landowners, nearly 1,000 of whom, public, municipal, and private, would be concerned. Crews of lumberjacks, inured to cold weather, plied their axes and chainsaws in the forests. All along the right-of-way, a 50-foot wide strip had to be swept clean of timber, whether small or large. Timber was valued by registered appraisers, and individual landowners were fairly compensated for it. They were paid, too, for any damage done to crops, fences, or other property. Here and there, in the wake of the lumberjacks, bulldozers not only completed the clearing operation, but also began biting into the soil to grade and level the right-of-way. The time had come to start laying pipe. Cars loaded with pipe joints 32 or 40 feet in length were being spotted at about 140 sidings along the route from which they would be stockpiled. They were 24 inches in diameter, for the biggest pipeline yet laid in Canada. Summer was upon the land. There were trailer camps now at several vantage points, and they were hives of activity at mealtimes. Out of a total force of around 2,500 people on the project, nearly 90% were Canadians. The rest were old pipeline hands from Texas, Oklahoma, and California, who trained as well as supervised the work of their Canadian friends, who quickly gained experience in the complexities of pipelining. Except at night and mealtimes, the trailer camps were almost deserted, for it was out on the line that most of the men earned their pay. At sidings near the camps, especially constructed trailers were loaded with steel pipe. Individual lengths or joints weighed up to a ton or more, and 150,000 tons of them would be needed. The 24-inch diameter pipe came in 7 thicknesses, from 1/4 to 1/2 inch, to be used in different locations according to the pressures it would have to withstand. Meanwhile, the right-of-way had to be given further treatment before it would be ready for the pipe. Where hard rock was struck, drilling had to be done. Powder monkeys placed dynamite into the holes, and the rock was broken up. Bulldozers kept up ahead, making right-of-way on level ground or around hillsides. And then came the ditching machines. Where the ground was soft, a ditcher could grind along, making a slot 3.5 feet wide and 5 feet deep at a rate of a mile a day. But sometimes the ground was too soft and too wet for a ditching machine, and then a backhoe was brought to bear. Now and then it got pretty soft for any kind of equipment. And sometimes it got pretty tough. Although the right-of-way traversed rugged terrain for many miles, less than 5% was rocky enough to require blasting. Once the ditch was dug, the pipe joints could be delivered to the right-of-way. After leaving the nearest railroad siding stockpile, the loaded pipe trucks kept on regular roads till they reached their destination, then turned off onto temporary access trails through the woods. Hundreds of such trails had to be opened up, and often existing rural roads had to be improved by the constructors to maintain their supply line. Carefully, one at a time, the pipe joints were lowered to the ground alongside the prepared ditch. In this operation, known as stringing, the joints were angled away from the ditch and barely overlapped to facilitate lining them up later. There were always inspectors around to make sure that the job was being done properly. In undulating ground and wherever the line changed direction, individual joints had to be bent to fit the contours of the ditch. Just ahead of the welders, men with emery wheels powered by portable motors cleaned the beveled pipe ends to ready them for welding. A side boom tractor picked up each joint and brought it into alignment with the one behind it, while a control rod attached to an internal clamp was threaded through. The clamp was maneuvered so as to grip and hold the two abutting pipe ends. A stringer bead was now applied to the joint. This was a critical operation, calling for sureness of touch combined with speed. Once the two ends had been linked by the stringer bead, the internal clamp was released and the next joint of pipe was brought into position. While the line-up men moved forward, hot pass welders put more metal over the stringer bead. Then came the firing line, a team of follow-up welders and their helpers who made 2 additional passes around each seam. The individual joints were literally blended together into a continuous tube, strong enough to carry oil at pressures from 500 to 1,100 pounds to the square inch, with plenty of strength to spare. To help maintain a uniformly high standard of welding, teams of X-ray technicians kept just behind the welders, photographing a representative number of seams. Practiced eyes scanned the film strips, and if any harmful irregularity or defect were revealed, a weld would have to be repaired or a new one made. The pipeliners took small streams in their stride. The pipe would later be buried well below the stream bed. Mobile construction equipment waded right across rivers that weren't too deep, without any snorkel attachments either. After the welders had done their work on the line, a self-propelled machine supported by a side boom tractor cleaned rust and scale off the surface of the steel with a battery of cutters and painted it with a primer. Behind the cleaning and priming machine came another self-propelled and still more complicated piece of mechanism. This was the coat and wrap machine. It performed several functions at once. It flooded the surface of the pipe with coal tar enamel at a temperature of 475 degrees, fed through a hose from a traveling kettle. Then it embedded glass floss in the coating for reinforcement, and finally wrapped the pipe in asbestos felt. Thus, the pipeline was protected from corrosion underground. Among the Rockies, in the vicinity of Jasper National Park, which is a game preserve, the pipeliners were often followed by volunteer scavengers. Discarded sandwiches and other food scraps were never wasted. Continuous sections of pipe as long as 4,000 feet were dealt with at a time where the terrain permitted. For tie-ins, the welders used external line-up clamps. Then the sections were welded together or tied in. Wherever a tie-in was made and wherever the insulation was bruised or incomplete, the pipe was generously doused with hot coal tar and wrapped by hand. The next step was to lower the pipe into its trench. The big tractors with their side booms gripped and held the pipe aloft in wide slings. Then, on signals from the foreman, the operators eased the line down into its prepared bed. Great care and skill were needed for this operation, which had to be done under a variety of conditions. Now, a top padding of soft earth was put over the pipe to protect its wrapping. Finally, a tractor with a handy dragline rig backfilled the trench. An important aftermath was the cleaning up operation. Fences were replaced wherever they intersected the right-of-way. In a short while, a new growth of vegetation would hide all trace of the pipeline lying silently 30 inches below the surface. During the fall of 1952, 5 separate spreads or outfits of pipeliners were hard at work. 3 between Kamloops and Jasper, a 4th near Edmonton, and a 5th in the Fraser River Valley near Vancouver. At the peak of the season's operations, the pipeliners finished 3 miles a day, and before they were forced by winter rain, snow, and frost to stop laying pipe for the season, they had filled in nearly half the total distance between Edmonton and Vancouver. But work in other branches of the project went on apace. The great tank farm at Burnaby, near Vancouver, had been cleared and graded during the summer and fall. In January 1953, steel for the first of its 150,000 barrel storage tanks was delivered and laid down in spite of rain and mud. The Burnaby tanks, with a capacity in excess of 1 million barrels, were being erected by Horton Steelworks Limited. In only a short while, the floor was laid. A floating roof was placed on top of it, and the walls were taking shape. Still another tank was rising on the Burnaby hillside. One after another, its great steel plates were hoisted into position. The vertical welding was done by hand, but the horizontal welding was speeded up by an automatic machine that moved steadily along, making a uniform weld of a strength equal to that of the plates themselves. And storage tanks were being erected and welded at Edmonton at the same time by Toronto Iron Works Limited. On a hill near Kamloops, bulldozers were grading right-of-way for spring pipe laying. They were approaching the highest point on the entire line, a plateau southwest of Kamloops with an elevation of 4,000 feet. From there on, it would be downhill. About 2/3 of the way from Edmonton to Vancouver, the city of Kamloops, right on the pipeline route, lies at the confluence of the North Thompson with the main river, just above Kamloops Lake. The landscape around Kamloops underwent a sharp change from summer to winter. In January, it was blanketed in snow and mist. On the outskirts of Kamloops, pipeline equipment lay in a storage yard awaiting reconditioning for its next season's work. But on the nearby banks of the Thompson, there was great activity. Its insulation protected by wooden slats and ringed with concrete weights, a section of pipeline was pulled across the river. A trench for the pipe at the river bottom was made by a suction dredge working in newly formed ice. The dredge had a small pipeline of its own to carry the sand and silt to shore. Taking advantage of low water, the pipeliners were installing a number of river crossings during the winter. In the Vancouver area, where the weather was mild but moist, preparations were made by Missouri Valley Canadian Limited for the greatest of all the 98 stream and river crossings on the project. Pipe sections 2 feet in diameter and a ½ inch thick, which had previously been triple coated and triple wrapped for corrosion protection, were now sprayed with a concrete mixture over reinforcing mesh. The pipe was next welded together in 2 long strings so that the bulk of the line could be pulled right across the river. It was the Fraser at Fort Mann, where its channel is 2,500 feet wide. While the pipe was being treated, a dredge dug a trench for it 15 feet below the riverbed, and the depth of the water at lowest ebb was around 40 feet. It was in March 1953 that the first section of pipe, its leading end temporarily plugged, was lifted onto dollies rolling on a track. Side boom tractors half towed, half carried the ponderous line to the north side of the Fraser. Like a fabulous serpent, it slithered into the depths. The layer of concrete covering it was 2.5 inches thick to weight it down evenly and to guard against abrasion. On the south side of the river, passers-by gathered to watch the proceedings. And here, a solidly anchored winch wound up a stout cable attached to the forward end of the long pipe section. When that section was nearly paid out, the remaining section was brought into alignment with it. The two sections were now welded into a single string weighing 680,000 pounds. The side boom tractors once again came into play, and the winch on the opposite shore wound in more cable. At last, the entire string lay in its trench, and only a small gap remained to be tied in at either shore. This gap had to be filled in with short, curved joints to conform to the sharply rising bank. To make sure that the line was properly placed, a diver inspected it from one side of the river to the other. Looming through winter fog and nestled in snow, a pump station was taking shape. It was one of 3 being built, at Edmonton and Edson, east of the Rockies, and at Kamloops on the western side. All this time, near Kamloops, hardy bulldozer operators were braving the elements. They were cutting down humps and ridges and smoothing the right-of-way. Before mid-March, pipe laying was again underway. On the Trans Mountain project were more than 100 prime contractors, subcontractors, and suppliers. Canadian firms, manpower, and materials were employed to the fullest possible extent. The principal contractors for the pipeline itself were Comstock Midwestern and Mannix Limited, but substantial mileages were also laid by Anderson International Contractors Limited and Canadian Pipeline Construction Company Limited. Where the ditch was flooded in muskeg areas, sections of pipe were tied together on higher ground and lifted, pushed, and floated into position. Nearly everywhere along the route, the pipe hands were destined to be plagued with wet weather all through the summer. They had to fight their way through swamps and quagmires, which were encountered on both sides of the Rockies. They had to summon all their patience and ingenuity. It was particularly trying with the intricate machinery of the coat and wrap outfit. There were moments when everything looked hopeless, but it was all in the day's work. Tractors were maneuvered to firmer ground. Steel cables were run from them to the bogged-down equipment. In a little while, the procession was underway again. 126 highway crossings and 46 railroad crossings posed special problems. Some were bored through. Others were of the open cut type. An unusual example of an open cut crossing was one just east of Edson, Alberta, at a bridge approach, where an excavation 22 feet deep had to be made in the customary mud. Then the pipe, 176 feet long in a protective casing, was laid on the bottom. An integral part of the building of the line was the installation of block valves at intervals of anywhere from 1 to 46 miles, depending on elevation, stream crossings, and other factors. From the beginning to the end of the line, there were about 85 of these big valves. Their initial use was for testing the line, isolating section after section, but in actual operation they would remain open except in emergencies. Besides regular block valves, there were automatic pressure limiting valves at low points to guard the pipe against overloading. As the summer wore on, work advanced rapidly on the pump stations. An important adjunct to the stations west of Edmonton was housing by Bennett & White Construction Company Limited. Eventually, there would be 100 or more comfortable dwellings for operators and their families at the several stations. Except for differences in setting, the stations were all much alike in design. Each was equipped with 3 big diesel engines directly coupled through speed increasers to centrifugal pumps. The Edmonton station would run on 95% natural gas and 5% diesel oil, while the others would burn 100% crude oil taken from the line. At the outset, 3 stations, capable of delivering 120,000 barrels per day, would be ready for operation at Edmonton, Edson, and Kamloops. These 3 were being built by Mannix Limited. A 4th station was to be completed by Marwell Construction Company Limited at the end of 1953 at Blackpool, 70 miles east of Kamloops. It would step up the capacity of the pipeline to 150,000 barrels per day. The design of the line was such that the rate of delivery could be increased to 200,000 barrels per day with 6 stations, and finally, as demand warranted, to 300,000 per day with 14 stations. As section after section of the line was completed, block valves were opened and water was pumped in for hydrostatic testing. Plenty of water was available, which was fortunate, for just to fill the line, 2 million barrels would be needed. The water came from 4 different sources at convenient intervals along the route. Scrapers were introduced into the line through traps at each of the stations and intermediate points. They ran along at 1.25 miles an hour, cleaning out rust and dirt, pushed by the water, which was pumped in at a rate of 75,000 barrels per day. Later, when the water was replaced by oil, similar scrapers would be run to keep the line free of wax. As soon as each section of line was filled with water, pressure was built up to 125% of what it would be during normal oil pumping operations. The testing period was 12 hours, and in one place the pressure went to 1,425 pounds per square inch. As rapidly as new increments of the pipeline were buried, the trench was backfilled and the right-of-way was restored to its former condition, ready for planting or any other surface use. Farmers were already able to observe that portions of the right-of-way where the line was completed in 1950